Algebra 2. And I'm finding myself in the studio booth, trying to find a proof of my leader to translate out to you. It's a chessboard waiting for my move. I don't move cause I move slow. When I move, you already know exactly what I'm in for. What you in for? Simple intros, better lay low. Handing out these lyrical halos. Hello, hey yo. You know I don't play though. And because I don't play, let's just start the math video that we were supposed to get started a long time ago. Okay, Algebra 2. So as you know, I'm feeling real happy. I'm feeling in a singing voice, and I felt like rapping. So let's actually do some math here, right? So, well, one of the things we want to be able to do, right, is we want to be able to solve using the quadratic formula when we're going to get complex numbers, meaning we're going to get numbers that don't exist because you get negative numbers under the square root, right? So this is actually one of the questions on the test, which is great because you need to do test corrections to do a retake. So let's look at this problem here. We have x squared plus 64 is equal to 0. Okay, there is two ways that we can go about solving this, and I personally don't mind which method you do. But this is the most efficient method, right? Well, see, we don't have a middle term in here, right? Usually we have something like, let's say, x squared plus, I don't know, 1x plus 64 is equal to 0. Okay. Well, see, now I would have to use the quadratic formula here, right? I get my a value, which is 1, my b value, my c value. But in this problem here, we don't have that middle term. So we could just solve it. We subtract 64 to both sides. So we subtract 64 to both sides, and we're going to get x squared is equal to negative 64. All right. Now, I'll go ahead and write it up here. We have x squared is equal to 64. All right, so what we're going to want to do now is we want to take the square root of both sides, right? And when we take the square root of both sides, this was my favorite, my favorite mistake. Don't forget to put your plus or minus, okay? So we need to put the plus or minus, right? Well, what's going to happen with the square root and the square? Bam! It's going to cancel, and we're going to get x is equal to plus or minus. Well, what's... Oh, snap! I forgot to put the negative in there. That, my friends, is what I called being way too silly, okay? So we take the square root, right? We get plus or minus the square root of negative 64, right? Well, here... what's going to happen when we have this negative in here? If you looked at the previous videos, right, this is where, I'll write it over here, I is equal to the square root of negative 1. Oh, shoot, someone's texting me. So this is going to be the square root of 64 times negative 1, which is x equals plus or minus the square root of 64 times the square root of negative 1. All right. Now, if we look carefully, well, we're going to get x is equal to plus or minus, well, what's the square root of 64? That's 8. And the square root of negative 1, we have defined that to be I. So it becomes I. Square root of negative 1 is just I. It's imaginary, right? So we get x equals plus or minus 8i. That's all we needed to do. Now, if we want to write this in vertex form, right? So let me go ahead and write it here. X equals and x equals. We have positive 8i. And we have negative 8i. These are my two roots, right? They're two non-real solutions. These are called complex roots, right? They're complex when they're not real. These are imaginary. So if we go to write this in vertex form, we get y is equal to x. Well, this is positive. So remember, it's going to be the opposite. So we're going to get minus 8i. And then over here, we're going to get x. Well, this is negative 8i. So now it's going to be positive. So plus 8i. All right. And there we go. This is factored form for our equation, right? They're imaginary roots. All right. And that's how we solve a problem like that. Now, you could use a quadratic formula and you will get the exact same thing if we did it, right? So let's go ahead and look at another example problem, right? This example problem was, again, another problem that was on your test. So let's do it. Do it. Okay, we have 2x squared. All right. Minus 6x plus 5 is equal to 0. All right, now in this problem here, I'm actually going to have to use a quadratic formula, right? If you look over here in the problem I provided above, there's no middle term like I talked about. So we could just subtract 64 and take the square root and solve. But here we actually do, right? We have 2x squared minus 6x plus 5, right? We do have this middle term. So we can't subtract the 5 because we have these two x's here and there's nothing for us to do. So we got to use the quadratic formula. So first thing I'm going to do is define a to be, well, the number in front of x squared, which is just 2, b is equal to the middle term now, that's negative 6. And c is equal to the last term, which is 5. There we go, okay? And for poops and giggles, I'll go ahead and just write the actual quadratic formula, right? We get negative b, and here we get b squared minus 4ac, that's me, Mr. AC, and then we get 2 times a. This is all equal to x. All right, now let's go ahead and just solve it. So let's go ahead and plug our values in and solve for this problem, right? So I'll go ahead, what I love to do, okay, in these problems is I actually like, right, to leave a blank in there, right? So I'll do that plus or minus the square root, all right, b squared minus 4ac all divided by 2a. And now go ahead, now that I have these values in there, I will go ahead and plug them in. Well, this is negative, this is b, so my value is negative 6, so I'll put negative 6 in here, right? This is b, so I'll put negative 6 in there, right? This is, the next term is a, so my a value was 2, so I'll put 2, and then this is 5 because it was c. And then over here, this is, well, 2a, this is your a value, which is 2, and so I put 2 here. Okay, so last but not least, let's go ahead and solve this down. We're going to get x is equal to, right, well, negative times the negative here is going to be positive, so we're going to get 6 plus or minus the square root, right? Now, like I told you before, I personally don't mind if you use your calculator. Matter of fact, I actually recommend it, right? So we get negative 6 squared. I'm just basically doing this inside part of the square root, minus 4a, which is 2, times 5, and we get negative 4. Wow, that's awesome. We get negative 4 all divided by, well, what's 2 times 2? That's right, it's going to be 4. Okay, so now let's go to simplify this, right? Well, we're going to get 6 plus or minus, all right, over here, this is going to be the square root of 4 times the square root of negative 1, right? This is all divided by 4. Okay, now we're going to get equal to, all right, this is negative 4, and I just broke it up. Square root of 4 times the square root of negative 1. Hopefully, you had enough practice now from the other videos in the practice package that should feel really automatic to you by now. So, we get 6 plus or minus, and what's the square root of 4? Well, that's 2. And what did we say the square root of negative 1 was? Well, that's just I. So we get I all divided by 4. Okay. Whew. Okay, now we just need to, again, simplify this further, right? So we're going to do, to simplify this further, what's 6 divided by 4? Well, 6 divided by 4 is 1.5. Then we're going to get plus or minus. And then we can't forget this part, right? When we divide the 4 with the 6, we have to still divide it with the 2 and the 4, right? So 2 divided by 4 is actually 0.5. And we get the I here, right? So this should be x, right? So now let's go ahead and write our two solutions, right? We're going to get x is equal to 1.5 plus 0.5i, and we're going to get x is equal to 1.5 minus 0.5i. All right, so now this seems kind of hard here, but how do we actually write this in factored form, right? Well, we just kind of proceed like we always do. Y is equal to, all right, you can't forget your dilation, right? And so our dilation is our a value. It's a number in front of x squared, and that's 2, okay? I should have made this clear, but if you look at the video up above here, right, the dilation value is just 1. It's like an invisible 1, which is why over here when I wrote it in factored form, I didn't write anything. It's just a 1. But over here at this other problem, right, well, we do have a number greater than 1 in front of x squared. So this is 2. Our dilation is 2. So we can't forget that. So we're going to get 2. Okay, parentheses, x. Okay, so let's just write the factor form of this root right here, right? This complex root. So what's the opposite of the 1.5? Well, the 1.5 is positive. So the opposite's going to be negative. So this is going to be minus 1.5, right? And now this is the only part that's tricky about these problems is that we do, well, what's the opposite of this? We write it down, but we still have to do what's the opposite of this, right? The opposite of the 0.5i. Well, because there's a plus sign, the opposite of that's a minus. So we're going to get minus 0.5i. Now we're going to get x. Well, if you look here, this is a positive 1.5i for this root, so it's going to be minus 1.5. Sorry, not 1.5i, there's no i there, but just minus 1.5. And now over here, what do you think this would be, right? This is minus 0.5i, so what do you think I'm going to get here? Well, that's right, you got it right. It's going to be plus because it's the opposite when we write our roots. And this is actually becomes my final equation here. All right, so if it's helpful, right, let's just say I gave you a different problem and I told you my roots were, let's actually just do just a random problem where let's say x was equal to negative 2 plus 3i and x is equal to negative 2 minus 3i. Well, if I was to write this in factored form, and let's pretend our dilation, our a value was 4, right? So let's say 4. So when we go to write this, well, we want to proceed the same way we've always have, right? We're going to do x. Well, what's the opposite of the negative 2? Well, that's plus 2. And then what's the opposite of the plus 3i? Well, that's going to be minus 3i. And then we go to do it again, x. Now we go over to this rule. What's the opposite of the negative 2? And that's going to be plus 2. And what's the opposite of the negative 3i? Well, that's just going to be plus 3i. All right, so this is just another example if I gave you those roots of how to write it into factored form, right? Hopefully that helps you to complete the problems that I handed to you, right? One last thing I'll mention as before we proceed with this problem here, last thing is sometimes you get problems like this, 2x squared minus 3x is equal to 4x plus 2, all right? Whenever we see problems like this, like you'll see on the packet, we want our y value to be 0. So it doesn't matter whether over here is 0 or over on this side is 0. We just want it to be equal to 0 because that's when our roots occur at, right? So you just need to make sure you move everything to one side. So for example, you subtract 4x from both sides, and we're going to get 2x squared minus, well, 4, 5, 6, 7, 7x. This is gone. It's equal to 2. All right, next step is we're going to subtract 2 to both sides, and we're going to get 2x squared minus 7x minus 2 is equal to 0. And then now I'll use the quadratic formula and I'll proceed to solve with this problem here, okay? And you'll notice when I did this, I organized it so that my x squareds first, then x to the 1, and then my constant term, right? So hopefully you'll see the problems and you'll just do it like this. You're just going to quickly rearrange it and then use the quadratic formula and solve for this and see what the roots will be. Cool. All right. Take care. Goodbye.